This is the worksheet on converting between standard form and vertex form. And what we can notice is that we can express a quadratic function in standard form, y equals ax squared plus bx plus c, or in vertex form, y equals a x minus p quantity squared plus q. And on this worksheet, we'll be converting from one form to the other. Vertex form is very useful. We know where the vertex is. It's at p and q. A tells us whether it opens up and if there's a vertical stretch, up or down, and if there's a vertical stretch. And over here, A tells us the same thing, but from here we don't really know too much else about it except for the C value, which we know is the y-intercept. Okay, so let's take a look. First, there's some stuff for you to read through here, and we can just take a quick look at this, and we'll see that we're squaring a binomial. We could do that using FOIL. Remember FOIL, x times x gives us x squared, that's the first. X times 5 gives us 5x, that's the outer. 5 times x gives us 5x, that's the inner. And 5 times 5 gives us 25, that's the last. But as you'll notice about all of these, a little mistake down here, that should be minus 7x, not plus 7x. If you notice about all of these, really the shortcut for squaring a binomial is to square the first term, to multiply the two together, minus 7x, double it, minus 14x, and then square the last term, which will always be positive because you're squaring a positive or you're squaring a negative, and you get 49. Okay, so let's move down and we'll do example number 1, convert each of the following to standard form. So in order to do this, we leave the 3. We're going to square the binomial. X squared, x times 5 is minus 5x doubled, minus 10x, plus the last term squared is 25, and we have the minus 17. Distribute the 3 through the brackets. 3x squared minus 30x plus 75, and still the minus 17. 3x squared minus 30x plus 58. Second example on the right side here, same procedure, y equals negative 1/2, that's our a value. Now we're going to square what's in the brackets. First term squared. X times 4 is plus 4x doubled, plus 8x. Square the last term, always positive, plus 16, and we have the plus 5 on the end. Multiply through by negative 1/2, negative 1/2 x squared, minus 4x, minus 8, plus 5, negative 1/2 x squared, minus 4x, minus 3. Okay, converting from standard form to vertex form, you can read the little blurb at the top there. But if we look at it, what we have is something that's a perfect square trinomial, and we want to get back to the square of a binomial. Well, how do we do that? You notice that half of 10 is 5. Half of negative 24 is negative 12. So to determine the constant term that completes a perfect square trinomial, you divide the coefficient of x by 2, and then square the result. Square the result. So moving down here, let's just do a little bit of practice on this. So we have x squared plus 12x. Half of 12 is 6, so plus 6 divided by 2, square the 6, you get 36. Half of minus 20 is minus 10, squared is always, and you notice they're always plus 100. Half of 7 is, and we got to keep the sign, so half of 7 is 7 halves. 7 halves squared is 49 over 4. And we're going to keep these as fractions. Okay, so the last thing we want to do then is just practice converting each of the following to vertex form. Okay, convert each of the following to vertex form. And here, we're really going to find out one of the advantages of being able to do this on the video, which is that you'll be able to see what's happening, because we're going to move from one line down below and then jump back up and fill something in, and we're going to go back and forth from one line to the next. And if you're just copying down notes off a board, you can't really see exactly what happened. And here you'll have the chance to rewind and go through it again, or to see multiple examples and watch as it occurs in real time, as opposed to looking at a static set of notes. Okay, y equals, and what we're going to do is place brackets around the x squared plus 8x, isolate that, and then have the minus 5. So what we want to do is turn this set of brackets into a perfect square trinomial, which factors as the square of a binomial. And we know how to factor that, right? It's x, half of 8 is 4, and keeps the sign, so plus 4. This will be the binomial, which when we square it will give us x squared plus 8x. But it actually gives us more, right? It also gives us plus 16. X plus 4 squared is x squared plus 8x plus 16. I've added the 16 on, so this line is now different from the line above. So we need to make it the same, which means we need to really subtract 16 from this. And I would do it inside the brackets, but I can just come out here and do it outside the brackets. And then we get x plus 4 quantity squared minus 21. If you expand this, if you convert it to standard form, it will convert back to x squared plus 8x minus 5. Now we'll have to handle things a little bit differently in b. Okay, b, y equals 2x squared. Now, in order to do any of this perfect trinomial square, we need to have just an x squared. So we're going to have to factor the 2 out of the x squared and the x terms. So x squared, negative 12x divided by 2 is minus 6x. Leave some space, and then put the plus 7. So the same idea, y equals, we're going to keep the 2. Now I want to make this the square of a binomial, and to do that, we know it has to be half of negative 6, so that'll be minus 3. X minus 3 squared will give us x squared minus 6x plus 9. Plus, if I can draw 9, plus 9. Now, in here, I really should subtract off the 9. Now, I'm not going to do it in here. What I'm going to do is subtract the 9, but there's this 2 out front. And the 2 out front is going to have to multiply this 9. So out here, I'm going to go minus 2 times 9. And I'm not actually going to draw it in there. So in future, we won't put it in there. But you can think about, well, if I add 9 on, I really should subtract 9 off. Okay, we're going to do it, but we'll put it out here. So negative 2 times 9 is negative 18, plus 7 is minus 11. And our completed square form, or the vertex form, is 2x minus 3 quantity squared minus 11. And again, if you were to expand this out, this is what we would end up with. Okay, let's do a few more. Next one, y equals negative x squared. Okay, now again, so in this case, I'm going to have to factor out a negative, because all I can complete the square on is I must have a positive x squared. So instead of plus 7x, this will be minus 7x. Leave some space, and minus 4. We come down to the next line, negative. This time we want to square a binomial. Always leads with x, always has this sign, minus. Half of 7 is 7 halves, or 7 over 2. Square the 7 over 2, and we get plus 49 over 4. Now, I really need to write minus 49 over 4 here as well, but it's going to be multiplied by this negative 1 coming out, so I'm going to subtract off, so I'm going to go minus negative 1 times 49 over 4. Coming down here, this gives me minus 4 plus 49 over 4. Let's change that. Let's make that 16 over 4. And so for a final step, x minus 7 halves squared. So 16 divided by 4 is 4. I've just changed it to have a common denominator. And this will be plus 33 over 4. A little more complicated with the fractions, but still the same idea as what we've been doing. Okay, 2 more. Okay, this time we have a minus 3 in front, so that's what's going to get factored out. Negative 3. Isolate the x squared term. That would give us negative 3x squared. Divide the 10 by negative 3, be minus 10 thirds x. Leave some space, and minus 2. We're going to come down because now we want to do the perfect square. It'll be x minus. Now in this case, it's half of 10 thirds. So what is half of 10 thirds? Oops, 10 thirds and a half. So I just got my scratch pad over here. So half of 10 thirds is 5 thirds. So back here we know we need minus 5 thirds, quantity squared. That gives us x squared. Minus 5 thirds x doubled is minus 10 thirds. Square the negative 5 thirds, we get plus 25 over 9. And so really I need to subtract off 25 over 9, but when I remove it from the brackets, I multiply it by negative 3. So I'm going to go minus 3 times negative 25 over 9. Now that's going to have a denominator of 9, so I'm going to write the 2 as 18 over 9, and this will become plus, and 3 times, oh wait, we're going to end up with the 3 canceling into the 9, giving us a 3 on the bottom, so let's back up a titch here. So I want thirds on the bottom. So I'm going to write this as minus 6 over 3. Now the negative times the negative gives me a plus. The 3 cancels into the 9, or reduces the 9, so plus 25 over 3, giving us a final answer. I forgot the 3 here. Okay, don't forget the 3 here up in front. Negative 3 x minus 5 thirds squared plus 19 thirds. Okay, it's always fun when fractions are involved, but you just work through, you follow each step carefully, and you're good to go. Okay, last one, y equals, we need to factor the 1/2 out, x squared. Now I got to divide by a half, or really I say half of what is going to give me 3? Half of 6. So that'll be a 6x, leave some room, and the minus 6 on the end. Okay, next step, we put the half. Remember last time I forgot to put the 3, I put the negative but without the 3. Okay, I need something squared. This is the binomial that we're going to square, plus to match that. Half of 6 is 3, and 3 squared is 9, so I go plus 9. Now I should subtract off 9, but I got to multiply it by a half, so I'm going to subtract minus 1/2 of 9. Okay, this will give me halves, so that'll be minus 6 is 12 halves, minus 9 halves, and our final 1/2 x plus 3 quantity squared minus 21 over 2. Remember the useful thing about vertex form. What do you know from this equation here? I know it opens up. I have a positive a value. I know that it's vertically stretched by a factor of 1/2, which would result in a vertical compression, or giving us a wider graph. And I know that the y-intercept, when x is 0, the y-intercept will be negative 6. What do I know here? I know the vertex is at I know all the above. I know that it opens up and that it's vertically stretched by a factor of 1/2. The a value is the same in both. But I also know that the vertex is, this moves left 3, the vertex is at negative 3, negative 21 halves, which means this I could sketch very easily, and this not so easily. All I would know is the y-intercept.